Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening. I shared the recording of areas related to circles. Did you watch that? Okay. All right, children. So continuing with the areas related to circles. Yeah. So look at this question. On a circular. Now what I'm going to do is today we're going to understand a bunch of questions. You will work it at home. I'll share the answers on WhatsApp later with you. Today we'll see, because it's completely numerical. You just have to know the sequence in which you have to answer the questions. Everything is formula based. You just need to know, supposing you have a circle, a triangle, an equilateral triangle, and whatever plane figures you have in the whole thing, the whole figure, you just need to know how to find their values. Like if you have a circle, but the radius is not given, how to find the radius. That idea you should know. Supposing there's a square, but the side of the square is not given to you. So you need to know the procedure to find the side of the square. So things like that. Then once you find them, the sequence is easy. Meaning it's all based on the formula. You just have to have the idea and find all the values using the formula and calculate. So we'll understand the ideas used to answer different questions. You will work them at home. I'll share the answers later. All right. So this one, on a circular table cover of radius 42 centimeters, we saw this in the last class from NCERT. Radius 42 centimeters, a design is formed leaving an equilateral triangle ABC in the middle, as shown in the figure. Find the area of the design. So I'll just help you recall the different methods we saw in the last class. So method one is join OB and OC. Join OB and OC. ABC is an equilateral triangle, meaning all the three sides are equal. The sides of the triangle are chords to the circle. The sides of the triangle, AB is a chord. AB is a side of the triangle and a chord to the circle. Similarly, BC and AC, they are chords to the circle. Now, since ABC is an equilateral triangle, the three chords are equal in length. All the three chords are equal in length. And we have learned this in standard 9 that equal chords subtend equal angles at the center. Equal chords. Why are they equal chords? Because it's an equilateral triangle, so the three sides are equal. Equal chords subtend equal angles at the center. So the measure of angle BOC, this angle, the measure of this angle is 120 degrees because 360 by 3. How many chords are there? 3 chords. How many chords? 3 chords. The 3 chords subtends. Okay, let me join this also and show you. Okay, so this is the angle AOB. AOB. This is the angle subtended by chord AB at the center. Angle AOB. This angle is the angle subtended by the chord AB at the center. BOC is the angle subtended by the chord BC at the center. And AOC, this is the angle subtended by chord AC at the center. So 360, this is a complete angle, right? All these three make the angle around the point O. So 360 degrees divided by 3, which is 120. So the angle, the sector angle is 120 degrees. So now how do you find the area of this piece? This one, it's the area of the sector minus the area of the triangle. The area of this region is equal to, see, now we found the sector angle. How? Because all the three sides are equal. So 3 equal chords, they make equal angles at the center. So 360 by 3, 120. So the sector angle is 120 degrees. So now you can find the area of the sector. The area of the sector angle is 120. So 120 by 360 into pi r square. R is given 42. Will help you find the area of the sector. This full thing, this sector. Okay. Now from this, you'll have to subtract the area of the triangle. If you subtract the area of the triangle, you will get the area of this piece. So how do you find the area of the triangle? R squared sine theta by 2 cos theta by 2 is the formula. Area of the triangle is equal to R squared sine theta by 2 cos theta by 2. So R squared, that is 42 into 42. Sine 60 degrees, cos 60 degrees. Theta by 2, 120 by 2. So sine 60 degrees, cos 60 degrees. Find the area of the triangle. The difference will give you the area of the segment. Now this answer into 3 will give you the area of the design. This answer into 3 will give you the area of the design. Correct? So we start off by finding the sector angle 120 degrees. Then from there we find the area of the sector. Then we find the area of the triangle. Area of the sector minus the area of the triangle. Triangle formula R squared sine theta by 2 cos theta by 2. Area of sector, area of triangle. The difference is the area of the segment. Now this one into 3 is the area of the design. Correct? Is one approach. Another approach we saw in the last class is that join O to B. Join O to B. All right. And drop a perpendicular from the center to the chord. Join OB and drop a perpendicular from the center to the chord BC. Let's call it OM. So OM is perpendicular to BC. Now I told you that OB is the bisector of angle B. This was explained in the last class. I'm not repeating that. OB is the bisector of angle B. O is the incenter as well as the circumcenter. O is the incenter as well as the circumcenter. Now when you join O, okay, now we treat O as the incenter. When you join the incenter to the vertex B, this line segment is the bisector of this angle. So now this becomes 30 degrees because the equilateral triangle, each angle is 60 degrees. So when it's bisected, 30 degrees. Now in this right triangle, see, we drop a perpendicular from the center to the chord. That's the construction. Drop a perpendicular from the center to the chord. This also we have seen in 9th standard. That's a construction. Draw a perpendicular from the center to the chord. And we know that the perpendicular from the center to the chord bisects the chord. The perpendicular from the center to the chord bisects the chord. So BM is equal to MC. That's easy. See, even if you don't know the theorem, you see, when you join this, these two triangles are congruent to each other. RHS rule, these two triangles are congruent to each other. Therefore, BM is equal to MC, CPCT. That's what we learn as a theorem. This is how we prove the theorem. 9th standard. So we have to show that these two triangles are congruent. So CPCT, we have BM is equal to MC. Okay, so but you don't have to do that. Just say the perpendicular from the center to the chord bisects the chord. So BM is equal to MC. Now using this right triangle, this angle is 30 degrees and the radius is 42. Now what do we have to find? We have to find the side of the triangle because for the circle, see, there are only two plane figures here, circle and triangle. Circle and triangle. Circle, you have the radius, so you can answer any question based on for the circle. Now for the equilateral triangle, you can find the side. You can find the side of the equilateral triangle. What else you want? For an equilateral triangle, what else do you need to answer any question? You just need the length of the side of the triangle. If you have that, you can find anything. So our intention here is to find the side of the equilateral triangle. So which one will help you to find the side? See, this is the triangle you have. This is the triangle you have. O, B, M, 90 degrees, 30 degrees, and 42 here. OBM, correct? Now, do you want to, using trigonometry, do you want to find OM or BM? BM, not OM. OM, what is OM for the triangle? What is OM for the, actually OM also you can find and do something else, but you can use the property of a median and do it. Okay, maybe that for in another, maybe on Saturday I'll explain that. Otherwise, with one answer will be pondering with many ideas. So remind me on Saturday, I'll tell you. You can also find OM and find the radius using the property of a median. Median divides, sorry, property of a centroid. Centroid divides the median, the ratio 2:1. We can do that. We'll see that idea in the next class. So now we'll find BM. We'll find BM. So how is that going to be useful? Because once you find, how do you find BM using trigonometry? You'll have to connect 30 degrees, BM and OB. You'll have to connect 30 degrees, BM and OB. Okay, so what is the ratio you will use? What is the ratio? Online students, how will you connect 30 degrees, BM and OB? What's the ratio? Sine, cos, tan?
Cos 30 degrees.
Cos 30 degrees.
Root 3 by
Cos
2.
Correct. Yeah, cos 30 degrees is equal to Shashank?
Root 3 by 2, ma'am.
Yeah, correct. Okay, completed. Cos 30 is equal to what by what?
BM by OB.
Very good. BM by OB. Cos 30 is equal to BM by OB. So like that, you can find BM. And once you find BM, double it to get BC. Double it to get BC. And BC is the side of the triangle. So here it is. Here, find the area of the circle. Here the procedure is find the area of the circle. Area of circle using the formula pi r square. Now you found the side of the triangle. So find the area of the triangle. Area of the triangle. How? Using the formula root 3 by 4 into side square. Because we found the side now. The difference will give you the area of the design itself. Don't multiply that answer by 3. You don't have to, right? The difference will give you the area of the design. This is the other approach. Using the radius, find pi r square, which is the area of the circle. Using BC and the formula root 3 by 4 a square, find the area of the triangle. The difference will give us the area of the design. You can also see, we know that this angle is 120. This is 120. Correct? This is 120. So when you drop a perpendicular from the center to the chord like this, see, it may be lengthy, but you can understand easily. Now these two triangles are congruent, right? So if this is 120, this will be 60 here and 60 here, right? So you can also use trigonometry. You can also use 60 degrees and apply trigonometry. We use 30, no? You can also use 60 degrees. You don't have to write in detail that these two triangles are congruent to each other. You just have to mention the names and say RHS rule, they're congruent. That is enough. You don't have to write this angle is equal to this angle 90 degrees. The hypotenuse here is equal. You don't have to write anything. You don't have to mention right angle, hypotenuse, side. Those three equalities you don't have to mention. Just say this triangle is congruent to this triangle. This is the congruence rule, RHS rule. That's enough. So these two triangles will be congruent to each other. So CPCT will have, this is 120, 60, 60. So you can use this right triangle, this angle 60 degrees and 42 centimeters here. So in the right triangle, connect 60 degrees, 42 and this one. So it will be sine 60, opposite by hypotenuse. Sine 60 is equal to opposite this one. Okay, opposite by hypotenuse, x by 42. Like this, you can find x. That is this one. And double it to get BC. And then the same thing, pi r square, root 3 by 4 a square and subtract. Now in this question, we have an incircle to the equilateral triangle. Here, equilateral triangle, circumcircle. Equilateral triangle, circumcircle. Here, equilateral triangle, incircle. Incircle. Now, what is given here? The side is 12 centimeters. The side of the triangle is 12 centimeters. Again, you need to find the area of the shaded region. So what's the idea? How do you find the area of the shaded region? Area of the triangle minus the area of the circle. Area of the triangle minus the area of the circle. For the triangle, we know the side. So root 3 by 4 into 12 square will give you the area of the triangle. Now for the circle, you need the radius. So what I'm saying is how to find the radius. That idea alone, you need to understand. I'll ask you. The others are easy. See, otherwise, if supposing I've given you the radius also, you know how to find the area of the shaded region, right? If you have the radius also, How will you find the area of the shaded region? Area of the triangle minus the area of the circle. So that is easy. Now, what is that extra thing you have to find? Radius of the circle. For the triangle, you know the side is 12 centimeters. For the circle, you don't know the radius. How to find the radius is what you have to understand and remember. The others are easy. The rest of the answer is easy. Yes, sir. You want to say something? Okay. So always, prioritize trigonometry in your mind. Whenever you, how to find this angle, how to find this side. Supposing you have a right triangle with you, and you need to find some part of the right triangle. Trigonometry should be the priority. So here, to find the radius of the circle, we use trigonometry. Now, recall that in circles, we have learned that the radius and the tangent at the point of contact are perpendicular to each other. Okay, so here OD is the radius, BC is the tangent, BC is the tangent. The point of contact is D. So we say that the sides of the equilateral triangle are tangential to the circle. Sometimes the figure will not be given. It will be explained. It will be given in words. So you should read that and make the diagram yourself. So for that, it becomes important to understand how this figure can be described in words. So here, the sides of an equilateral triangle are tangential to the circle. That means the circle is the incircle. That means the circle is the incircle. If the sides of an equilateral triangle are tangential to the circle, that means the sides act as tangents to the circle. If the sides are tangents to the circle, that means the circle is an incircle to the equilateral triangle. So you should draw a figure like this. Now, the thing is we need to find the radius of the circle. Trigonometry. Now, we know that OD is perpendicular to BC because BC tangent at the D and OD is the radius. So this is 90 degrees. Join this one. Now we know that OB, now because this is the incircle, this is the incircle. So this is the incenter. Incenter and the vertex of the triangle, when you join, the angle is bisected. When you join the incenter, when you join the incenter to any vertex of the triangle, that angle is bisected. That's how the incircle is constructed. I told you in the last class, since we don't have the construction of incircles and circumcircles in our syllabus and CBSE, you have to remember this like a theory. You have to believe me, that's all. Now, if you have a question like why, when you construct, that's why constructions are important, but constructions is deleted from the portions this year. From this year onwards, we don't have constructions, but constructions are important because when you do something practically, the properties you learn, you cannot forget. Even if you want to forget, you cannot forget. Because you've actually performed it. You've actually performed it. Like it's like, a small child. We say, supposing we have lit a candle. The flame the child doesn't. What? But if the child accidentally does it, I don't want any child to do that. I'm just saying you. But if the child accidentally happens to touch the flame for fun, just flicks the flame like this, and when it burns its finger, that's a lesson for life. It will not do it again because practically, it now knows what it is to touch the flame of a candle, burning candle, right? So similarly, good or bad experiences, when it is practical, it's for life. You cannot forget it. So constructions play a very, very vital role in understanding the properties of whatever constructions you perform. But unfortunately, it's removed from the syllabus. Like this, we have construction of incircles, circumcircles, where we understand the properties very clearly. But now, yeah. So remember that when you join the incenter to any vertex of the triangle, that angle is bisected. So now we are connecting the incenter O. Why do we call it the incenter? Because we have the incircle and O is the center of the incircle. So incenter. Circumcenter is the center of the circumcircle. In-center is the center of the in-circle. When you join the in-center to the vertex B, this angle is bisected. And it's an equilateral triangle, so this is 60 degrees, so it becomes 30 here. Now in this right triangle, OBD, we have 30 degrees here. Correct? What else we have? We know BD. How much is BD? 6 centimeters. Because you can join this and show that these two triangles are congruent to each other. You can join this and show that these two triangles are congruent to each other. So CPCT, this full thing is 12. This full thing is 12 because equilateral triangle, all the sides are 12. So it's going to be 6 here and 6 here. So in this right, it's a right triangle. See, all these parts you should remember. Why is it a right triangle? Because OD radius, BC tangent at D. So radius tangent at the point of contact perpendicular to each other. That's why 90 degrees. And then how does 60 become 30? Because because OB bisects angle B. So 60 degrees by 2, 30 degrees. Correct? So we have a right triangle with one angle 30 degrees and one side 6 centimeters. Now what do you want to find? You want to find OD because OD is the radius of the circle. You want to find OD because OD is the radius of the circle. It's centered and D is the point on the circumference. OD is the radius. Easy. So you have to connect what? 30 degrees, OD and BD. Yes, what's the ratio? Dileepan, what's the ratio? Yeah, opposite by adjacent is? So what's the ratio, children? Yeah, tan 30 degrees. Tan 30 degrees is equal to opposite by adjacent. Tan 30 degrees is equal to opposite by adjacent, OD by BD. So like that you can find OD. So now you have the radius of the circle. Now the idea, find the area of the triangle, √3/4 a square. Find the area of the circle, pi r square. Difference will give you the area of the shaded region. So that part is very easy. So the thing is, we know the idea, but how to find the area of the circle? I don't have the radius. So how to find the radius? That idea you need to remember. That's all. There's nothing to practice in these sums. You just have to remember. So what you have to do in this chapter is take an A3 paper. Draw all the figures you come across. Whatever we do here, draw all the figures. And just write the details given. Like for this figure, the side of the triangle is given. Just write side as, or you can just write side of the equilateral triangle is equal to 12 centimeters. That is enough for you. And you know what is to be found. The shaded region area has to be found. So now you know. So look at the figure and tell yourself, like, meaning recall as to how to find the radius. That's all. So take a big paper, the one which is bigger than A4, A3, and draw all the figures. Don't write the question. Don't write all these in words. Just draw the figures. I think you can accommodate up to easily about 30 figures in one A3 paper, depending the size you draw. But this size you can accommodate about 30 figures. So 2 sides you can accommodate all the figures in areas related to circles. So it's so easy. The whole chapter is in front of you. Just write the information which is given. What is to be found is easy. That shaded region should be found, or you write in short whatever has to be found. And write that information which is given. If like the radius is given, side is given, whatever, just write that. So your work is to see the figure and understand how to find that missing value. So it could be trigonometry, it could be some other idea. So how to find that missing value? That idea you have to recall. That's all it is. So this chapter is, if you do that, it's as easy as drinking water. It's very, very easy because it's completely formula. Only to find the missing values, we use some other idea. Otherwise, it's just formula everywhere. So this is how we find the radius. Using trigonometry, we find the radius. So once you find the radius, you know what to do. So that's what I said. Prioritize trigonometry. If you have to find some angle or side, trigonometry should come first. Yeah, online children. Any questions or shall we move on?
No,
Online children? Okay.
I'm not.
Yeah, online children use the emoji, raise your hand. Yeah. Rajat, Sashank, Florentina. Florentina, you joined late, is it? Danya
Yes,
also,
ma'am, I was-
Raghavi also. Ranjan,
I was
Krishni, Arjun. Yeah, why?
completing the test, ma'am. I came home from school late, that's why.
Oh, okay. All right. All right. So in this figure, the shape of the top of a table, the shape of a top of a table is that of a sector of a circle. Is this a sector of a circle? The shape of the top of a table is that of a sector of a circle. Is this a sector of a circle? Major sector, yeah, it is. It is a sector of a circle. What's a sector? It's a region bounded by two radii and an arc. It's a region bounded by two radii and an arc. So OA and OB are the radii and the arc you can see, the major arc. If I mark this as C, ACB is the major arc. So this is a major sector. It's a sector, it's a major sector. OACB is the major sector. What is the major sector angle? Huh? What is the major sector angle, children? Why online students? What is the major sector angle? 2?
Ma'am, angle AOB.
No. My question is, what is the measure or what is the magnitude of the major sector angle?
Ma'am,
270, ma'am.
270. 270 because it's 90 degrees here. It's 90 here. So this one is 270. This is 270. Now, what is the question? To find the perimeter of the top of the table. So tell me that, the formula. We don't have a ready-made or a fixed formula. The formula, now according to this situation, we generate one formula, right? Correct. Based on this figure, we generate a formula. So what is the formula for this situation? How do you find the perimeter of the top of the table? Louder. That's it. You're right. That part is online children. Florentina.
Miss,
Ma'am,
Yeah, please. Yeah, anybody, please answer. What is the formula? Now for this situation, what will be the expression or what is the formula to find the perimeter?
area of the circle minus area of the triangle.
No. The question is not to find the area. Find the perimeter of the top of the table. Perimeter, length of the boundary.
Circumference of the circle minus perimeter of the triangle.
Okay, that, this method of subtracting holds good only to find area, not perimeter. See, now going back to the earlier one, the area of the shaded region will be area of the triangle minus the area of the circle. When you have to find the area of the remaining portion, then you can do the area of the bigger one minus the area of the smaller one. Perimeter does not work like that. Perimeter is not perimeter of the circle because that is the full thing. It's like from the circle you have taken away the sector, no? It's like from the full circle, the sector is removed. Actually, yeah, from the complete circle, a sector with sector angle 90 degrees is removed. And the remaining portion is what we see here. If you have to find area, that is one of the ways of finding area. Area of this region is equal to, as Florentina said, area of the circle, because that's a full thing. minus whatever is removed minus the area of the sector. Of course, we can directly find using the formula 270 by 360 into pi r square. That's a different thing. But for finding area, you can apply that logic. Area of the circle, because that was the full thing originally, minus whatever is removed. What is removed? A sector with angle 90 degrees is removed. So area of circle minus area of the small sector minus sector is area of the major sectors, correct. But that idea does not hold good for perimeter. For perimeter, you cannot say perimeter of the circle minus the perimeter of the sector which is removed. No. For length, that holds good for area and volume. For area and volume, you can do that. The volume of that big thing minus whatever we remove is the area of the, the volume of that big thing minus the volume of whatever is removed is the volume of the remaining thing. Volume, you can do that. To find the remaining volume, original volume minus the volume removed is the remaining volume. So for volume and area, you can do that. Not for perimeter, not for any length.
Ma'am, can we use 360 minus 270 by 360 into 2 pi r?
Oh, that sounds sounding very complicated for me. I have to process that. Come again?
360 minus theta divided by 360 into 2 pi r.
Okay, this will give you the length of what? Let me mark this point as C. Let me mark this as C. Now this will give you the length of which one? This will give you the length of what?
Arc, ma'am, major arc.
Correct. Yeah, you're right. It will give you the length of the major arc. Name the major arc. I've marked the point C there.
ACB.
ACB. Very good. You're right. Yes. So see, children, this is what I said. When you're using the formula 360 minus theta, don't write 360 minus 270. Here, theta is the angle in the minor sector. Don't write 360. Don't write 360 minus 270. When you're finding the length of the major arc, you have to use the major sector angle. So if you are writing, write directly 270 by 360 into 2 pi r. Don't write 360 minus 270. That theta there is the minor sector angle. You should do 360 minus 90 if you want to use this formula. It is 360 minus 90. See, the angle is, you should take the corresponding angle. Now you want to find the length of the arc ACB, right? So what is the angle in that sector? 270. So 270 by 360. If you want to find the length of this arc, what is the angle in that sector? 90. 90 by 360 into 2 pi r. So you can just remove that. This I told you the other day itself. This is just for the sake of a formality that we have this 360 minus theta by 360 into 2 pi r. You can directly take the angle. The relevant angle by 360 into pi r square, or the relevant angle by 360 into 2 pi r. If you want to use this formula, then you should substitute for theta, you must use the minor sector angle. Minor sector angle, 90 degrees. Okay. Fine. So yeah, you're right, Danya. So 360 minus 90, that is 270 by 360 into 2 pi r will give you what? The length of the major arc ACB. Will give you the length of the major arc ACB. Okay, then that's all. Okay, so Navya has already answered the remaining part, plus OA plus OB. Because perimeter is the length of the boundary. Just imagine there's a park in your neighborhood in this shape. There's a park in your neighborhood in this shape. The compound of the park has this shape. And if you walk, like around the park or along the boundary of the park, so how will you walk? So you start from O. So you'll walk along the path OA, which is the radius. Then you'll walk along the major arc ACB, ACB. Then you'll walk along the path BO and you'll come back to the starting point. Perimeter is all about Going along the boundary, you start from a point, you walk along the boundary and come back to the starting point. You should not cross over, you should not get inside the figure. You should not get inside the figure. If there are line segments inside the figure, so like if there's a line segment here like this, for example, like this, you're not going to walk on all these line segments. You're going to walk only on the boundary. So you start at any point. You start at any point. Say you start at O. Okay, well, let's start at A. So from A, you walk along the major arc, ACB, ACB. So from A, you go one arc like this and you reach this point B. Now from B, you walk along BO and you reach O. And from O, you walk along OA and you come back to the starting point A. So these lengths you have traveled together make the perimeter of the top of the table. These lengths, you walked along some path, right? You walked along the boundary. So you walked along one arc and two line segments. You have walked along one arc and two line segments. Add all this. That is the perimeter. That's the perimeter. So it is OA plus the length of the arc ACB plus BO. So how much is the radius? 42. So 42 plus 42 plus. So the perimeter of the tabletop is equal to OA plus length of arc ACB plus BO or OB, whatever. This is the formula. This is the formula. This we generate according to the situation. It's not a fixed thing that you memorize this. This one we have, got this based on the situation. Or we have framed this based on the situation. So OA plus length of the major arc ACB plus BO. So what is it? It's 42 plus 270 by 360 into 2 pi r. So here also children go wrong. By mistake, pi r square. Pi r square is for area. Here you're not finding area. You're finding the length of the arc. That is 2 pi r plus 42. Yeah, understood, children? Any questions?
No, ma'am.
Okay. Am I clear, Florentina?
Yes, ma'am.
Okay. No, you're sure? I would repeat, meaning I don't mind repeating if I'm not clear.
I understand.
Okay. So no subtracting to find the length of the boundary. Only for area volume you can subtract like that. For finding the perimeter, you should always add all the line segments or the arcs you have. Should put everything together. Okay. Let me just give you question based on a situation like this. See here, where we have to find the perimeter. Now, supposing you have a figure like this. Okay, so here we see three semicircles. We see three semicircles. So the radius of these two semicircles, 14 units, centimeter, meter, whatever, 14 units. Now tell me what is the radius of this one? Radius 7. Radius 7 centimeter. Okay, radius here
7.
7. Yeah. And radius here 14.
14.
Correct. Now tell me. Use R1, R2, R3 and frame the formula or the expression to find the perimeter of this region. Perimeter, not area. Take your time. Take a minute and tell me correctly. Don't substitute the number. Just use R1, R2, R3 and tell me. Engen square வருது. What's the what? I said find the give me the expression to find the perimeter of this region. Perimeter lenga r square. Huh? Sector. Yeah. Yes, I've got the answer from one student here in the class. Somebody online tell me. What is the formula to find the perimeter of this region? This region meaning this full figure, children. My question is clear. This full thing. No, today the online children are lazy. Why?
2 pi r3 square r3 plus 4 plus 4 plus 4 pi r1.
எனக்கு பயமா இருக்கு. No, like when children come up with different answers, now I have to, understand that. No, I don't know how you're getting 4 and all that. I'm sorry.
2 semicircles are there, so. But the r is different for all the.
Yeah, that's what r is different. See, that's what my question was very clear. I said use r1, r2, r3 and tell me the formula to find the perimeter of this region. And I also said don't substitute the values, just give me using r1, r2, r3.
R1 and R2 are same, right?
It's okay, yeah, but they're two different regions, no? Yeah, you can use R1 only for both. That doesn't make any difference.
That is why, ma'am, 2 pi R1 plus 2 pi R2 is equal to 2 times 2 pi R1, which is equal to 4 pi R1.
No, you treated us two different things only. Use R1 and R2, I said.
Ma'am, is it pi R1 plus R2 plus R3?
Okay, you mean this one? Do you mean pi R1 plus R2 plus R3 like this?
No, ma'am, pi taking in common.
Yeah, perfect. Very good. Yeah, very good. Sashank, you may be right, but this is what I wanted. Danya and Dileepan. Very good. Because the length of a circle is 2 pi r. The length of a semicircle is 2 pi r by 2 pi r. See, I'll do it here. This is a different question. I'm just doing it here. The length of a circle is 2 pi r. The length of this one, this semicircle, only this arc. The length of only this arc. Full arc means 2 pi r. Half of it will be 2 pi r by 2. So pi r. So the length of this arc, which is a semicircle, is pi r. The length of this arc, which is a semicircle, is pi r. Because the full thing is 2 pi r. So this one is 2 pi r by 2. Half of it, pi r. Now come back. The length of this one, this is a semicircle. So the length of this one will be pi r1. Because if it's a complete circle, its length is 2 pi r1. The next one, if it's a complete circle, 2 pi r2, 2 pi r3. No, they are only semicircles. Okay, so they are only semicircles. So on half of it, from here to here, the length, pi r1. From here to here, length, pi r2. And this one is also a semicircle. Length, pi r3. So pi r1 plus pi r2 plus pi r3 is the formula to find the perimeter of this region. You should not add this line segment. You should not add this line segment because when it's perimeter, you're just going along the boundary. Whatever line segment or arcs you have on the boundary, only those lengths you should take into account. So when you're going on the boundary, don't get into the figure like this. On the boundary, one arc, which is a semicircle, another arc, which is a semicircle, and another arc, which is also a semicircle, and you come back to the starting point. So it's pi r everywhere. So pi r1 plus pi r2 plus pi r3. So when you work questions like this, you should not take the value of pi. Pi r1, so 7 pi. Pi r2, 7 pi. Pi r3, 14 pi. So the perimeter is 7 pi plus 7 pi plus 14 pi, which is 28 pi. Now use the value of pi 22 by 7. So 28 into 22 by 7. 7 ones are 7 fours are. So 88 centimeter. Everywhere you should not use the value of pi. You are spending more time in calculating. Whenever you think you have to add many things which have pi in them, whenever you have to add many things that have pi in them, don't take the value of pi everywhere. Or like what Danya did, take pi common. Take pi common. Or if you're finding it separately, don't use the value of pi. Find the answer in pi like we did, 7 pi, 7 pi, 14 pi. Then the total length is 28 pi. Now once for all use the value of pi 22 by 7. So that makes your work easy. Or you can take pi common like this and there will be pi into 7 plus 7 plus 14. And so this question is very simple, yet we go wrong here because sometimes we'll find only this length. We'll find only this length. We'll say perimeter of this, this figure is 270 by 360 into 2 pi r. 270 by 360 into 2 pi r is the length of only this major arc. 270 by 360 into 2 pi r is the length of the major arc, and that is not the perimeter completely. Perimeter is plus this plus this. This makes it a closed figure. So the perimeter of this region is radius plus theta by 360 into 2 pi r. So don't go wrong here. Very good. Yeah, this is the next one. Area of this tabletop will be 270 by 360 into pi r square. That's all. It's only one region. It's only one region. It's the major sector. Just one region. Nothing to add there. So this is the major sector and its area is 270 by 360 into pi r square. So I'll just explain this figure to you. The circle with center O represents a pulley. The circle with center O represents a pulley. The pulley, the circular one, which is also used to draw water from the well, the one which is fixed on the top, and the rope passes through the pulley, right? The rope passes through the pulley. So similar thing. So that's a pulley. That's a pulley there. And there's an elastic belt. So you have to visualize this. Visualize it. You have a pulley and on the rim of the pulley, meaning like on that circumference of the pulley, there's an elastic belt. I don't have anything circular. That's what I'm looking for. You can remove that. Yeah. Thank you. So here. Yeah, so this is the pulley. And this is the pulley. And on the rim is this one. On the rim of the pulley, there's an elastic belt. So the elastic belt is completely in contact with the rim of the pulley. The elastic belt is completely in contact with the rim of the pulley. Now what you do, it's boring. So what you do, you just pinch the belt here. You pinch the belt and you just stretch it like this. You pinch a small portion of the belt and you stretch it like this. And that's the figure given here. That is the figure given here. Those line segments inside OA, OB, all that is not seen in this figure. That is to show the radius of the pulley. Leave that. Can you see that portion outside the circle, outside the pulley? Yeah, that's what it is. So this is the pulley and there's an elastic belt going around the rim of the pulley. Now what you do, you pinch the elastic belt and you stretch it. You take it a little away from the center. You pinch it and pull it away from the center. When you do that, when you try to represent that diagrammatically, it looks like this. So you're pulling it to this point P. All right. I'll have it. Maybe I'll. All right, children. So that's what this figure, indicates. OA and OB, radius of the pulley. P is that point to which the elastic belt is stretched. So now there is the elastic belt here, which is still in contact with the rim of the pulley. There is the elastic belt here, which is still in contact with the rim of the pulley. See the elastic belt here. This is still touching the pulley. This is still in contact with the rim of the pulley. Now this part of the elastic belt is not in contact with the rim of the pulley because you have stretched it. This one is still in contact with the rim of the pulley. Now this one is not in contact with the rim of the pulley. Now you will have to answer two questions. One is you need to find the length of the belt, the elastic belt, the length of the elastic belt that is in contact with the rim of the pulley. And also you'll have to find the area of the shaded region. Find the area of the shaded region. Find the area of the shaded region. The two questions you have to answer. Okay. Now, to find the length of the belt that is in contact with the rim of the pulley, this one is nothing but the length of the major arc. It's just the length of the major arc, nothing else. Should not add the radius and all that here. Just the length of the major arc. Just the length of the major arc will give you the length of the belt which is in contact with the rim of the pulley. And the formula is theta by 360 or 360 minus theta by 360 into 2 pi r, whatever. Correct? That angle by 360 into 2 pi r, correct? Angle we don't know. So first we have to find the angle. To answer the question, length of the belt, we have to find the sector angle. We don't know the sector angle, that's not given. So we need to find the sector angle. So I said, whenever you have to find missing angles or sides, think trigonometry first. Think trigonometry. But to use trigonometry, you need right triangle. To use trigonometry, you need right triangle. So we have to find for a right triangle, then use trigonometry and find the sector angle. So that is what we need to first do. Once you get the sector angle, you know the radius. Radius is given. Radius is 5. Radius we know. For the circle, we know the radius. We only don't know the sector angle. So mostly if we find the sector angle, we can answer this question. We can answer the two subdivisions in this question. So now the sector angle. So now to find the right triangle, OA is the radius. And AP acts as a tangent. When you stretch the belt, this one acts as a tangent. AP is the tangent. OA is the radius. So this is 90 degrees. So we got a right triangle. Now in this right triangle, we need to know two things. We know two things. The distance between O and P is 10 centimeters is given here. Is given. And the radius is 5. So in the right triangle OAP, it's a right triangle because OA is perpendicular to AP, radius perpendicular to tangent. So in the right triangle, we know two things. Radius OA is 5 centimeters and OP is 10 centimeters. We need to connect these two with the angle you want to find. So you want to find theta. Because once you find this one and this one, they are congruent to each other. You can prove are congruent to each other. So whatever is this will be here also. If this is 45, this also will be 45. So the sector angle is 90, like that. Okay, so how do you connect? How do you connect theta with 5 and 10 centimeters? In right triangle OAP, tell me. Adjacent by hypotenuse, very good. Because this is the right angle. This is the right angle. So OP is the hypotenuse. Adjacent by hypotenuse, correct. So adjacent by hypotenuse is what? Sine cos tan. Adjacent by hypotenuse is sine or cos or tan?
Cos.
Cos. Cos. Okay. Cos theta is equal to adjacent OA by hypotenuse OP. So
1
cos
by 2,
theta,
which is equal to cos 60. Angle is 60 degree.
okay, very good. So cos theta is equal to 1 by 2. When is it 1 by 2? Cos theta is equal to cos 60 degrees. So theta is equal to 60 degrees. Very good. Very good. So theta is 60 degrees. So what's the sector angle? 60 plus 60, 120 degrees is sector angle. So this is not at all difficult for you. But the thing is, you should think of trigonometry. So for trigonometry, you need right triangle. And in the right triangle, you should know two things, any two things. Any two things. So here the two things we know are OA and OP. So we connect those two knowns with the unknown theta. Very good. So like this, we found theta. And we found the sector angle, 120 degrees. So now tell me, how do you find the length of the belt in contact with the pulley? What's the formula? What's the angle? Tell me the angle straight away, no? 270. 270 by 360 into. Oh my God. See, not 270. 120 is a sector angle, right? 120 is a sector angle. So 360 minus 120, 240. 240 by 360 into 2 pi r. 2 into 22 by 7 into r. What is r? 5. They've given you the instructions. Take pi as 3.14. So you'll find the length of the belt. Well, we found the length of the belt now. Next, find the area of the shaded region. Find the area of the shaded region. So to find the area of the shaded region, you can find the area of this triangle. You can find the area of this triangle, subtract the area of this sector. Find the area, because this is a right triangle. No, this one is a right triangle. So you can find the area of this right triangle, subtract the area of this sector, whose sector angle is 60 degrees, not 120. This sector angle is only 60 degrees. This one is 120 and this one is 240. This is only 60. So find the area of this right triangle. Find the area of this sector with sector angle 60 degrees. Subtract, you'll find the area of this region. Into 2, you'll get the area of the full region. Or what you can do, you can find the area of this triangle. Double it, you will get the area of the quadrilateral. Double the area of the triangle, you will get the area of the quadrilateral. OAPB. The quadrilateral is made up of 2 right triangles. This quadrilateral is made up of 2 right triangles. Okay, so you can find the area of the right triangle OAP, double it to get the area of the quadrilateral. And from that you can find this, subtract the area of this sector with sector angle 120 degrees. You will get the area of the shaded region directly. Do it both the ways. Find the area of the quadrilateral. How? Find the area of one right triangle, double it, you will get the area of the quadrilateral OAPB. From the area of the quadrilateral, take away the area of the sector whose angle is 120 degrees. How do you find that area? 120 by 360 into pi r square. The difference will give you the area of the shaded region, correct? That also you can. All right, children. Yeah, something now this is for you. How do we find the area of the shaded region? I'll just come back in 5 minutes. Tell me, how do we find the area of the shaded region? Yeah, children, anything to share? Yeah, anyone wants to share your idea?
Ma'am,
Yeah.
Area of two semicircles plus area of triangle minus area of semicircle.
Correct. Correct. Very good. So we'll first understand how this figure is made. There is a right triangle. There is a right triangle. Now this right triangle is ABC. Angle A is 90 degrees. On the side AB, a semicircle is described. On the side AC, another semicircle is described. This is the full figure. This is the boundary of this figure. There is something else in this figure, but that runs in the middle. The boundary of the figure is this one. I'm saying the maximum part of the figure is this one. There is a right triangle. There is a semicircle on AB. There is another semicircle on AC. This is the full figure. Now from this, if you take away the area of this semicircle from this one, that is, what is this one? Area of the right triangle plus the area of the semicircle on the side AB plus the area of the semicircle on the side AC. These three regions, if you add, will give you the area of this total figure which you see here below. Now from this area, if you take away, if you cut this one, just imagine this. Imagine you have a paper cutout of a design like this. Okay, now what you're doing, using a pair of scissors, you're cutting a semicircle like this with BC as diameter. You're cutting a semicircle with BC as diameter. So BC is the diameter. You're cutting a semicircle like this here with BC as diameter. You're cutting a semicircle like this. So now what will remain? Only this will go. This is cut off. This one is cut off. This is not there. Only this one and this one are there, right? And that is a shaded region. That is a shaded region. Now, your question will be, now how do you know that the semicircle will pass through A? What if it doesn't pass through? Again, going back to 9th standard, we know that angle in a semicircle is a right angle. Angle in a semicircle is a right angle. So because this is 90 degrees, if you draw a semicircle using BC as diameter, it has to pass through A. Angle in a semicircle is a right angle. So this is the semicircle with diameter BC. So it will pass, that semicircle will pass through A because A is 90 degrees. It will pass through A. So first you need to understand the complete figure. The complete figure is a right triangle. So area of the right triangle plus area of semicircle with AB as diameter plus area of semicircle with AC as diameter. This is the area of the total region. Now you're cutting off, you're taking away a semicircle from this. The semicircle has BC as diameter. That is, a semicircle is drawn using BC as diameter. So that's what you're cutting away now. So you cut off a semicircle. You cut off this one. You cut off like this. This is removed. From this figure, this is removed. The semicircle with diameter BC is removed. So what remains is only this one. This one remains. And that's exactly what we have to find. So the idea here is area of the triangle plus area of semicircle plus area of another semicircle minus the area of the biggest semicircle will be the area of the shaded region. So now formula to find the area of the triangle, half base into height. Semicircle's area pi r square by 2. But r is different. R is different everywhere. That's all. So that's what I told you. Everywhere it's just formula. You need to know the values. Now here radius. So you need to know R1, R2, R3. If it's a triangle, base and height you need to know. That's all it is. And the idea. So To find the area of the right triangle, half base into height. 1 minute, this is 21, this is 28. So using Pythagoras theorem, you should find BC. BC, 784 plus 441. 784 plus 441. 35. This is 35 by Pythagoras theorem. All right. So the radius of this semicircle is 21 by 2. So there also we'll go wrong. See, here, 50% chances of going wrong. Because, like, okay, maybe now we are doing all from circles at a row, so you may go wrong. But in the exam, you'll just have 1 or 2 sums like this. So you may be able to think correctly, but still, tendency to go wrong is in taking the values of R. If the diameter is given, we just take it like that for R. So be careful there. Diameter, this 21 is diameter, not radius. So 21 by 2 is the radius. 28 is the diameter because what is attached to the semicircle is the radius. Oh, diameter. What is attached to the semicircle is the diameter. What is attached to a quadrant is the radius. Quadrant is radius. What is attached to the quadrant is the radius. Radius has, sorry, quadrant has 1 arc and 2 radii like this. Quadrant, 1/4 of a circle. Semicircle has diameter and an arc like this. So if the semicircle, this is the diameter. Quadrant, radius. (21, 28, 35). So 35 by 2 radius, 28 by 2, 14 radius, 21 by 2 radius. Don't take the decimal value. You can take it as 21 by 2 itself. That 2 and something else will get cancelled. 22 by 7 is already there, right? Pi r square by 2. That's pi 22 by 7, right? So this is 21 by 2. So 2 and 22 will get cancelled. So don't take the decimal value. Don't take 21 by 2 as 10.5 and 35 by 2 as 17.5. Don't do that. Take it as 35 by 2. Radius is 35 by 2, 21 by 2. So area of the triangle is half into 21 into 28. Correct? Semicircles pi r square by 2. That's all. So how to present the answer? Find the area of the triangle, half base into height, have that answer. Then find the area of the, you can mark the regions like 1, 2, 3. You can mark the regions. 1, you can mark this region 1, region 2. Okay, now region 3 cannot be marked. So then what you can do is you can write like this, area of triangle ABC. Then you can write area of semicircle with AB with diameter AB like this. Then area of semicircle with diameter AC. Then area of semicircle with the diameter BC. Like this you can write. Now when you're finding the area, pi r square by 2 or half into pi r square. Half into pi r square. Don't use the value of pi. If you have values that you can get cancelled, like I think here 21, 28, yeah, you can use the value of pi. So that's what it depends on the situation. So here you have 21 and 28. So then when you write 22 by 7, 7 and 21, 7 and 28 will get cancelled. Then take the value of pi. If it's not divisible, don't take the value of pi. You can have everything in pi and then once for all you can substitute. Just remember these ideas. Once you work, you will get it clear. Here you can take pi as 22 by 7 because you have multiples of 7 here, 21, 28, 35 also. You have multiples of 7. So you can present your answer like this. Area of triangle ABC, then area of semicircle with diameter AB, area of semicircle with diameter AC, area of semicircle with diameter BC. Then add the first 3, subtract the last. And then radius also you can say R1 here is equal to half into pi into R2 square, because you'll have to differentiate, no? Then R3 you can use. So again, see, you can call this 1, you can call this 2, you can call this 3, and then what will be 4? Adding all this, that result is 4, correct? Adding all this, that result is 4. Then result 5 is the area of the semicircle with BC as diameter, that is 5. Now the required area is equal to 4 minus 5. Like that you should present your answer. Just mark the different stages as 1, 2, 3, 4, 5. So 4 is 1 plus 2 plus 3 is 4. Then the required area is equal to the answer you have in 4 minus the answer you get in 5. Yeah. This also. Think. I'll give you some time. Think about this and then we'll discuss.
Area of
Yeah.
area of rectangle minus area of segment.
Correct. Area of rectangle minus area of segment. Correct. So now we have to find the area of the segment. So what is the sector angle? All right. So here again, Sashank told us the main idea, like as to how to find the area of the shaded region. It's the area of the rectangle ABCD minus the area of the segment AXB. Segment. Segment is a part of a sector. A sector has a triangle and a segment in it. A sector has a triangle and a segment in it. So the area of this rectangle is, the area of the shaded region is area of the rectangle minus the area of the segment. Okay, that's correct. Area of the rectangle, easy to find, length into breadth. Okay, segment, also easy to find, no? Area of the sector minus the area of the triangle there. Find the area of the sector, we need the sector angle. So first we have to find the sector angle. Now to find the sector angle, trigonometry. Think anything, think trigonometry. Anything, trigonometry will help you. Okay. All right. So you can use trigonometry, or we can also use Pythagoras theorem here, because the sector angle is 90 degrees. It's going to be 90 degrees. So now see this figure, children. See this one. I'm just showing you the triangle alone. Online children, use the emoji. Raise your hand. Prashant, Florentina, Danya, Prajit, Kushni, Ranjan. Arjun, are you there? Arjun? You're sleeping. Exams are going on or what? Ranjan?
It's over, man.
Okay, so he's taking rest after the exams, maybe. All right. Yeah, children. So, yeah, thank you, children. So coming back to this one. So this is the triangle OAB. All right. How much is the OA? 10√2. Because OL. Now, it's not given that this figure is a semicircle, but you all have a doubt? No. And one more thing that confirms this is a semicircle is what? Huh? No, that's not given, no. No, even if AOB is 90, that doesn't make it a right. No, that's not a reason.
Ma'am,
OL
LF
is
a
equal
diameter.
to OM, ma'am.
Huh?
OL is equal to OM, ma'am. Radius
Correct.
are equal.
Correct. The other thing is O lies on LM. O lies on LM. See, LM is a straight line, no? LM is a straight line. All that will not be given. In 6th and 7th sense, that will be given. LM is a straight line. So here LM is a straight line. And O lies on LM. The center of the circle lies on LM. So LM is a diameter. The center of O normally represents the center of a circle. And O lies on LM. So LM is a diameter. O is the center of the circle. That means this whole thing is a semicircle. Okay. So that semicircle, I'm just showing you this triangle there. AOB. OL radius. OM, let's write out all the radii we see. OL, OM, OA, OB. All the line segments emerging from the center to the circumference. OL, OA, OX also. See, it's not there, but OX is also radius. Okay. So OA,
Ma'am, but they
OX.
haven't given that angle O is 90 degree.
It's not given. We have to find. It's not given, it's 90. OL, OA, OB, OM, all radius, correct? So that means OA is 10√2. And this one, OB is also 10√2. Correct? And how much is AB? How much is AB? 20. AB is 20. Now we all know how to apply converse of Pythagoras theorem. Which is the longest side? Huh? 10 root 2 or 20? 20. Because 10 root 2 is what? 10 into 2 only is 20. This is 10 into root 2. Root 2 is smaller than 2. 10 into 2 is 20, but this is 10 into root 2. Root 2 is smaller than 2. So 10 root 2 is less than 20. 20 is the longest side. So what is 20 square? 400. And what is 10 root 2 the whole square plus 10 root 2 the whole square? 400. 400 is equal to 400. That means it's a right triangle. We can check the converse of Pythagoras theorem. In triangle AOB, assuming that let me not say like that. In triangle AOB, by mistake, sorry. In triangle AOB, the longest side is AB, which is 20. Correct? Okay. Square that side separately. Have the result. Now take the remaining two sides. Find the sum of their squares. That's how Pythagoras theorem works, right? So find the sum of their squares. Find OA square plus OB square. Get the result. 400. Equal. That means by converse of Pythagoras theorem, the angle opposite to the longest side is a right angle. By converse of Pythagoras theorem, the angle opposite to the longest side, AB is the longest side. The angle opposite to the longest side is a right angle. So that means this is 90. We find out it's 90. It's not given. Like this, you can find out it's 90 degrees. Because in right triangle AOB, by converse of Pythagoras theorem, AB is a hypotenuse. So opposite the hypotenuse, this is 90 degrees. It's one way of working. So once you get the sector angle, it's easy. So you should find the area of the sector. Find the area of the sector minus the area of the triangle will give you the area of the segment. Then area of the rectangle minus the area of the segment will give you the area of the shaded region. It's all about finding the sector angle. The sector angle is 90 degrees. 90 by 360 into pi r square will give you the area of the sector. Area of triangle, you can do half base into height. Or if you do r square sine theta by 2 cos theta by 2 also, you'll get the same answer. What you will get using half base into height, same thing you will get here also. So you can do half base into height quickly. Subtract, you'll get the area of the sector. Segment, then rectangle is 20 into 10, 200 minus segment will be the area of the shaded region. You can also find the sector angle using trigonometry. But for trigonometry, you need a right triangle. So we have to construct a line segment from O perpendicular to AB. Construction. You can always do that. Draw OM, okay, not OM, OP. Draw OP perpendicular to AB. Because we need right triangle if we have to use trigonometry. Draw OP perpendicular to AB. Now you can prove that these two triangles are congruent to each other. This one and this one. Okay, that you have that result. They're congruent by RHS rule. Right angle, hypotenuse OA is equal to hypotenuse OB, radius, and OP is a common side. So RHS rule, the triangles are congruent. CPCT, you have this angle. This angle is equal to this angle. That result we need later. Now, Pythagoras for trigonometry, this one is, how much is this one? 10 root 2. This one is 10 root 2. How much is this one? 20. This one is 20. This one is 20. No, I think so. Now we have to prove congruency first. Only then you can say AP is equal to BP. So we have to do congruency first. So let me come again. Draw OP perpendicular to AB. Show that these two triangles are congruent to each other. show that these two triangles are congruent to each other by RHS rule. CPCT, this angle is equal to this angle and AP is equal to PB. But AB is 20 centimeters. So this one will be 10. This is 10. So now take up the right triangle. Right triangle, because this is 90, children. This one is 90. Construction, that's 90. Not the sector angle is 90. This one is 90 by construction. And now by CPCT, we got this one is 10. We already know this is 10 root 2. This is A, this is P, this is O. In right triangle OPA, angle P is 90 by angle P is 90 by construction. Angle P is 90 by construction. We draw OP perpendicular to AB. That we don't get by CPCT. Construction, draw OP perpendicular to AB. Then we prove that the triangles are congruent. Okay, then so AP is equal to BP, correct? RHS rule, AP is equal to BP. So 20 becomes 20 by 2, 10, 10. Is this figure understood? OPA, 10 root 2, 10. Now you need to find this angle. You need to connect this angle with these two. So for this angle, this is the opposite side, this is the hypotenuse. So what is it? Sine. So you can also, you can mark theta here, or you can also write like the sine of angle AOP. You can also write like this. Sine of angle AOP, not that you should mark theta. You can just name the angle. Sine of angle AOP is equal to opposite 10 by hypotenuse 10 root 2. So it's 1 by root 2. When is it 1 by root 2? Sine 45. Sine 45 degrees is equal to sine of angle AOP. So angle AOP is equal to 45 degrees. Angle AOP is equal to 45 degrees. So this one is 45. So the sector angle is 40. This is 45. This one is 45. So this is also 45. So the sector angle is 90 degrees, which we got using converse of Pythagoras. So these different ideas you must remember. So some new situation, how do you do that correctly using all these ideas? So all this is just, you're just accumulating, you're trying to understand different approaches, different ideas, different situations to find certain things. You use some idea, right? You must remember all this. It's not about working 50 sums as far as this chapter is concerned. It's about recalling, rehearsing the ideas, the different ideas. That's what I told. Right, draw all these figures on a paper. Just see the paper and tell yourself. So if you see this figure, you must say you should draw OP perpendicular to AB. Then you should show that these two triangles are congruent to each other. So we'll get AP is equal to BP. So 20 becomes 20 by 2, 10. Like that, you must rehearse. You must teach yourself. Then all these ideas will be registered. Of course, calculation, you should be careful. But there's nothing to work much in this chapter. Now don't say this at home and say, I'm not working because teacher told us don't work. There's nothing to work in this chapter. You all understand that I'm not communicating that. Correct? Yeah. I'm not saying don't work. Give more importance to the ideas. Work, but rehearse the ideas more often. So here we have an incircle in a right triangle. We have an incircle in a right triangle. We already had an incircle, no? Yeah, see here. Here we have an incircle in an equilateral triangle. So here the approach was different. Now that approach we are going to do now, we can apply that here also. What we are going to see there, that will be a different approach. That can be used here. This cannot be used there. This equilateral triangle approach is unique. It can be used only here. We cannot use that approach here. But what we're going to do now here can be applied to that figure also. Now, what is that approach? So here you see for the triangle, you know all the sides. You can find AC using Pythagoras theorem. You can find AC using Pythagoras theorem, correct? So it's about the area. So see, the area of the shaded region is area of the right triangle minus the area of the circle. So right triangle area easy, half base into height. Circle radius is not given. Circle radius is not given. So the thing is to find the area of the circle. Yeah. So I was telling you that for the circle, we don't have the radius. So that's what we have to find. So here the idea is you need to connect the in C, it's marked I. Why I? Because in center. In center, so I. It's also, you can also call it O, but it's called I because it's in center, because it's in circle. The triangle is a right triangle. Now join IA, IB, IC. So now we have divided the whole triangle into 3 smaller triangles. Now for each of the small triangles, show the altitudes. Now, point of contact, point of contact, point of contact. As we understood earlier, the 3 sides of the triangle are tangential to the circle. The 3 sides of the triangle are tangential to the circle. So these are the points where the tangents meet the circle. We connect the in center to the points of contact. In center to the points of contact. So radius and tangent at the point of contact perpendicular to each other. First step is to join IA, IB, IC. Connect the in center to the vertices of the triangle. That is step 1. We have divided the whole triangle into 3 smaller triangles. Now for each of the small triangles, we need their respective altitudes. We then mark off the points of contact M, N, and P. Points of contact M, N, and P. All right. We joined IM, IN, and IP. IM radius and AB tangent at M. So 90 degrees. Correct? Okay. Now this is the idea. The area of the whole triangle is equal to the sum of the areas of these 3 small triangles. Area of triangle AIB plus area of triangle AIB, then BIC plus area of triangle AIC is equal to area of the whole triangle ABC. AIB, BIC, AIC is equal to the area of the whole triangle ABC, correct? Now what's the area of the triangle? AIB, half base into height. Half into, tell me the base. Somebody online, tell me. Half into?
AB into IM.
IM, very good. Plus, somebody else online? Half into?
IP into BC.
Yeah, 1 second. Half into?
IP into BC.
Yeah, base BC into height IP. Plus here somebody, half into? AC into NI or IN. Okay, very good. Now is equal to area of the whole triangle ABC. For that, half into, which is the base and which is the altitude. BC into
AP, ma'am.
We don't know how much is AP. And AP is a broken two broken lines. It's not a straight line. Right triangle, half product of legs. AB into AC. AB formula to find the area for right triangle is half into product of legs. Legs are the two sides other than the hypotenuse. Leave BC. Let go the hypotenuse. The other two sides, AB and AC, are the legs. Half product of legs, half AB into AC. So now substitute half into AB is 6 into IM is the radius. Plus half into BC is 10 into IP radius. Plus half into AC. We can find using Pythagoras theorem 8. 8 into IN radius is equal to half into base into height. Base AB is how much? 6 into AC. Now, don't you think? So what do you get? 3R. When you cancel 3R plus 5R plus 4R is equal to 24. 3R plus 5R plus 4R is equal to 24. 12R is equal to 24. R is equal to 24 by 12. R is equal to 2. So we found the radius. So remember this idea, dividing the whole triangle into 3 smaller triangles. So when you do that, you should know the base and the altitude of the 3 smaller triangles. Base we know 6, 10, 8 we know. Altitude, so you should join the point of contact and the center to get the altitude. Because that will already be 90 degrees, radius and tangent perpendicular to each other. So we found R. Now how will you find the area of the shaded region? What's the idea? Area of the triangle minus the area of the circle. Correct. Area of the triangle minus area of the circle. For the circle, we did not have the radius. That's why we didn't know how to find the area. Now we found the radius. So area of the triangle minus area of the circle will give us the area of the shaded region. So in today's class, you have collected different ways of finding the unknown values to find the areas of the plane figures. So recall, meaning reinforce, practice this, reinforce, and you must remember these ideas always, because these are very elementary for your age. These are too simple for your age to remember. The ideas are too simple for your age to remember, right? Yeah, it is. Okay, now I think you can, all of you can start. You can take an A4 sheet and whatever figures we have seen so far, I'll share all the images on WhatsApp. Make a rough sketch, or you can take a printout. I don't know. There are different ways now, or you can draw whatever. Maybe, I don't know. Fine. I don't know. If you have a printer, probably you can just take a printout and just cut out those shapes and stick everything on a A3 paper. That will be very useful. All right. All right, children. Any questions? Any questions, online students?
No doubts, ma'am.
No doubts, ma'am.
All right. Okay,
No,
I'll
ma'am.
share all these. All right, children. Thank you. So I'll share all these images on WhatsApp. Not with the answers. I want you to work. I told you. I want you to work. I'll share the answers, but not now immediately. After Saturday, I'll share the answers. But by Saturday, finish working all this. Okay, so maybe I'll show you the answers in the class also. I'll share the complete answers on WhatsApp later. I'll share all the answers, but please finish this work by Saturday. I'll share the questions with you. All right. All right, children. So that's it for today's session. Thank you so much. Good night. Thank you, children.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, children. Good night. Yeah, thank you, Krishna.